measures angles with a pointer that dangles. And this is what we need for making it. Card paper, a protractor from your geometry box, some strong thread, a long needle, small stones, straw, some adhesive, a long ruler, and some sticky tape. Here's how to make it. Take a rectangular card paper. Align the protractor and mark its outline. Mark the degrees. Mark the exact center. Start drawing the radials. You are making an instrument that has to measure angles. Start writing the degrees. Observe how. 0 at the center. Then next to it 10, 20, 30 and so on. The other side would also go the same way. Starting with 0 in the center and 10 right next to it. Then 20, 30 and so on. Again, you will go up to 90. Thread the needle. Use a fairly long, thick and heavy needle. Poke a hole at the center point. Watch your fingers. Pull the needle right through so that you have thread hanging on either side. Snip the thread, and now you have to tie the two stones on both ends to make the pointer. The weight of the stone will keep the pointer taut. Your angles are ready and so is the dangle. But one more step to go. The straw has to be stuck on top of the card sheet. Use the sticky tape. Don't squash it. You will need to look through it. You have another option, that of sticking a protractor on the sheet directly. Make sure that the angles are all aligned. A heated needle to poke the plastic protractor. You may need adult supervision. Again, pass the thread through and tie the stones as in the first design. Your angle dangle meter is now ready for use.
बिल्डिंग का माप नहीं सकते पर अंदाजा तो लगा ही सकते हैं।
कितना बड़ा होगा?
कम से कम 1-2 किलोमीटर के बीच में।
Guessing the height of the building is tough. The no can change to a yes. Let's measure the height of the school building. Keep the card close to your eye and look through the straw. You have to find a position from where you are able to see the top of the building, and the angle on the angle dangle meter is 45 degrees. Exactly 45. The next step is to measure the distance of the angle dangle meter from the base of the building. Use your own method, whether a measuring tape or a string that you would measure later. It's your choice. This distance done, measure the height of the child who was holding the angle dangle meter. Cut the entire length. Measure it. You have a string as long as the distance from the building of the angle dangle meter plus the height at which the angle dangle meter was held. And congratulations, you've just found the height of your school building. But how do you verify? Well, not tough in this case. The children drop the entire measured rope from the top of the building. Does it reach the ground? Hardly any margin of error. The school building is 11.8 meters tall. The angle dangle meter is indeed a handy instrument. But why does this work? It uses the basics of geometry. It's based on the principles of triangle. When the angle of the angle dangle meter is 45 degrees with the top of the building, what we have is an isosceles triangle. Two angles of 45 degrees each, and the third one is a right angle. As we all know, the two sides of such a triangle are equal in length. So height equals the base. So the height of the building equals distance of the angle dangle meter plus height at which it stood. Whether a flag post or a tree, the height of just about anything can be measured with the angle dangle meter. But the angle dangle meter is also called the latitude finder. Have you figured out why? Spot the pole star, the Dhruv Tara. All stars will appear to move in the sky, but not the Dhruv Tara. Its angle is always fixed for any place on earth, and that is the latitude of the place. That is why the North Star is also called the guiding star. Remain curious, remain scientific, remain imaginative. Write your responses to us at Surat Zameen Par, Vigyan Prasar, A50, Institutional Area, Sector 62, Noida 201309. You could even email us